Okay, this is question number 22 from the EOC review problems. It states that the vertices of a triangle are at 0, 0, 6, 6, and 9, 3. What is the volume in cubic units of the figure created by rotating the triangle about y equal x? Okay, so let's plot the points. Zero, 0, 6, 6, and 9, 3. Okay, so here's the triangle formed. Okay, then it says that we are to rotate this about y equal x. Okay, well, what does y equal x mean? That's all the ordered pairs where the x and the y coordinates are the same. So 0, 0 would be on the line y equal x. 6, 6 would also be on the line y equal x. Also 7, 7, 8, 8, 9, 9, 10, 10. You could come back to -1, -2, but you can see where that line is. So this is the line y equal x. They're asking us to rotate the triangle around this line. In other words, we're going to spin the triangle everywhere except for this piece right here is going to stay where it is, and everything else is going to spin around that. So as it does so, it's going to come around, it's going to look like this. Something like that. And it is going to create a cone shape as it spins. Okay? So this is the figure that was created by rotating around the line y equal x. All right, now they ask us to calculate the volume of this figure. So we need to use the formula for the volume of a cone. Okay, so if you recall, if you just had a regular cylinder with straight sides, that would be the base times the height. The base would be the area of the original base, the area of the circle times the height of the cylinder. Because this one's a cone, it's tapered off to a point, so the volume of a cone is 1/3 the base times the height, or 1/3 the area of the circle times the height of the cone. So our job is to figure out the area of this circle, and if we can figure out then the height of the cone from here to here, we'll have what we need to answer the question. Okay, so to get the area, so to get capital B, all right, capital B is the area of the circle. I need the formula for the area of a circle. So, get a sheet of paper. So for capital B, that's going to be the area of a circle. And that is pi r squared. So you need to know that formula. That's pretty basic. We need the area, we need the radius of this circle. So the radius of this circle, I can see this was the center because that was where it was spinning around. And then this was the measurement on the side. So the distance from this point, basically from 6, 6 to 9, 3 is my radius. Okay, but how am I going to find that distance? I can't just count them because it's a diagonal line, so I'm going to have to use it. I'm going to use a distance formula, which I'm thinking you probably did in Math 2. I'm sure you did it in Math 1. The distance formula is the square root, and then you subtract the x coordinates and square, plus subtract the y coordinates and square. So we're going to do that for 6, 6 and 9, 3. Okay, so calculating that is going to be the square root. All right, so let's say I'm going to do 9 minus 6 square plus parentheses, and then subtract the y's, 3 minus 6 and square. So I have square root of 3 square, which is 9, plus 3 minus 6 is -3, square that, it gives me 9. So I have the square root of 18 for my distance. So that tells me that my radius here is the square root of 18. So the radius equals the square root of 18. Circle that because I need that, that's important. All right, so we've got this measurement here, square root 18. What else do we need? To get the volume, we need to calculate this distance from here to here. That's the height of the cone. So again, it's on a diagonal. I can't just count the spaces. I'm going to use the distance formula to calculate the length from 0, 0 to 6, 6. So doing that, I'm going to say, so this is for my height. I'm going to say d equals the square root. I'm going to subtract the x's from here to here. So 6 minus 0 square plus 6 minus 0 square that one. So the square root of, that's 6 squared, which is 36. 6 squared is 36. That gives me a square root of 72. So that's my height. All right, so that means that the volume is going to be 1/3 times, we found our base, the area of the circle, to be, did we do that? I think I forgot to do that part. Okay, so we found the radius of the circle was the square root of 18. So capital B is the area, so it's just going to be pi times square root of 18 square. So that's going to be pi times 18, or just 18 pi. Okay, so B, area of the circle was 18 pi. So we'll put that in. And then the height we found to be square root of 72. 72. Square root, sorry about that. I will rewrite this. Volume is 1/3 times 18 pi times the square root of 72. Okay, so all we have to do now is just simplify all this and we'll have it. So 1/3 times 18, that's 6. All right, and then to simplify square root 72, let's do a factor tree on the 72 and break that down. You could say 8 times 9, and then 8 is 2 times 4, and 2 times 2. 9 is 3 times 3. Any prime number that appears twice in your factor tree can come out of your square root. So you could pull a 2 out, and you could pull a 3 out. And then inside, you still have this little 2. Oh, I'm sorry. This little 2 has to stay inside. So we have the volume equals 6 times 2 is 12. 12 times 3 is 36. Pi square root 2. Okay, so that's what we're getting, and this is cubic units. All right, so let's see if we have that as a choice. 36 pi square root 2. And there it is. It's letter C is our answer. So 36 pi square root 2 is the answer to 22.